In this video, I want to talk about the definition of something called similarity. And similarity has a lot to do with what we've been talking about lately in terms of scaled copies. So the first sentence reads that we have been talking about scaled copies of images where all of the corresponding side lengths are enlarged or reduced by a certain scale factor, and we use the variable r. So the actual mathematical word that is used for this is the word similar. And the symbol for this word is this squiggly symbol. You might recognize this symbol. It's the top part of the congruence symbol. I'll do this off to the side. You don't need to write this down. But remember, the congruence symbol was an equal sign with a squiggle above it, and that meant that the shapes were the same size and the same shape. But with similar shapes, they are simply just the same shape, but they're not necessarily the same size. So let me write that down here. So a similar shape is the same shape, but of a different size. Okay, there is an important two properties that that occur whenever we have two similar shapes. So when two figures are similar, then all of the corresponding angles are congruent. So all of the angles are congruent in two similar figures. And the second property is that all of the corresponding sides are proportional. So again, two figures are similar when all of the corresponding angles are congruent and all of the corresponding sides are proportional. So using these two properties, let's look at this example really quickly here. It says that triangle ABC is similar to triangle DEF. So triangle ABC, all of the corresponding angles from triangle ABC are congruent to all of the corresponding angles in triangle DEF. Also note, it says is similar to, and you replace that with this little similar symbol. So let's look at the angles. Angle C is congruent to angle F because those are corresponding, they're in the same spot. Angle B in this triangle is congruent to angle E in this triangle because they're corresponding and they're in the same spot. And angle A in this triangle is congruent to angle D in the other triangle because they are in the corresponding spots. So that's what it says down here. Those list all of the pairs of congruent corresponding angles. And then over here, the ratios of the corresponding side lengths are all going to be the same. So if you take each side of triangle ABC and you scale that, you scale by some scale factor r, then the new sides all become multiplied by r. And if you took the ratio between this triangle and this triangle, of triangle DEF and triangle ABC, and you found the ratio between any corresponding sides, you will always end up with this scale factor, which is r. So let's summarize what this means. This means that if two polygons are similar, then the ratio of any two corresponding lengths and when I say lengths, I mean sides. So the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So this is so similar to the concept we've been talking about lately with scaled copies. If you find any two corresponding sides or any two corresponding lengths and you write the ratio between them, that ratio will be the scale factor. So that concludes the notes on the front page. please turn to the back and let's talk about similarity with a few examples here. So on the back, it looks like they want us to do similarity statements first. So let's do that. Okay, so it says in the diagram we have that triangle RST, so triangle RST, which is right here, is similar to triangle XYZ. Okay, we can look at this diagram and we can already make the observation that the triangle is getting smaller, so the scale factor should be between 0 and 1. And they want us to find that scale factor. Well, you can always use this method of the new over the original. I know a lot of us are getting confused with which side do you choose first and which one do you choose as the bottom. So use this idea of putting the new over the original. So if triangle RST is our original, that's where we're starting, then triangle XYZ is our new. So we're starting with this triangle and we're moving to this triangle. So this is our original triangle and this is our new triangle. So if I want to know the scale factor to get from this yellow triangle to this blue smaller triangle, I'm going to pick any new side and then pick the corresponding side on the original. So I'll pick this side. I'll do side ZY, which is 18, and I'll correlate that and I'll make a ratio with the corresponding side on the original triangle, which is 30. So 18 over 30 is my scale factor. I'm not sure if this comes out to a nice decimal. Okay, so it comes out to 6/10. You also can reduce this. So we know that 18 and 30 are both divisible by 6. So that's going to give us 3/5. Okay, so the scale factor you could say is 3/5, or if you want to keep it as a decimal, you can write it as 0.6. And just to show you on my calculator, 3 divided by 5, if I hit enter, I get 0.6 exactly. So it doesn't matter if you use the fraction or the decimal for the scale factor here. Part B wants us to list all of the pairs of the congruent angles. So this just means find the corresponding angles that are congruent in the two triangles. So we know angle R and angle X. Angle R is congruent to angle X. We know angle T is going to be congruent to angle Z. So angle T is going to be congruent to angle Z. And lastly, angle S is going to be congruent to angle Y. Those are all corresponding angles, and corresponding angles are congruent whenever you have similar triangles. So there's example 1. Let's move on to example 2. I will do letter A with you, and then I want you to hit pause on this video, and I want you to do letters B and C on your own. So let's do letter A together right now. Letter A says that we have triangle DEF congruent to triangle MNP. So all that means, again, when you see the similarity symbol, all that means is these two triangles are scaled copies of one another. So they want us to find the value of X, and X is right here on triangle DEF. So all I have to do to find X is do exactly what we've been doing in the past. Set up a proportion. So I'm going to pick this side and this side because those two sides correspond in both triangles, and this side has the X in it, which is what I want to find out. And then I just need to pick one more pair of corresponding sides. So it doesn't matter what I choose. I'm going to choose the 15 and the 18. You could have chosen something different, but that's just what I'm going to choose for my example here. So if I say 15 from this triangle correlates with 18 in the bigger triangle, to stay consistent with my proportion here, I'm going to say that the X from the smaller triangle correlates with the 30 in the bigger triangle. From here, we're just solving for x, and we're just solving a proportion. So cross multiply, you're going to get 18x equals 15 times 30. 15 times 30 gives you 450. And then you want to get x by itself, so you divide both sides by 18. And 450 divided by 18 gives us 25. Okay, so that means that the missing side, the x, was 25. So at this point, I want you to hit pause, and I want you to try letters B and C. Go. Okay, so here are the answers to parts B and C. As you can tell, the most that I've done is color code and show you how I set up my proportions, but I did not show much work beyond that. So please do not just copy this. It's not going to help you with your understanding. The purpose of this is just to show my work and give you the answers so that you can check with what you have done. And if something is wrong or you found a mistake, please pause the video before going on and fix that mistake. So I'll give you a few seconds to make that assessment right now. Okay, if you are good to go on example 2 with parts A, B, and C, let's move on to the very last example here. Example 3, finding area of similar polygons. So there's that word similar again. This idea relates to what we talked about last week as well, with when you scale a figure by a scale factor, the area gets scaled by the scale factor squared. So let's see, we have triangle ABC, and that triangle is similar to triangle DEF, again meaning they are scaled copies. It says that the area of triangle ABC is 36 square centimeters. And they're asking us to find the area of the smaller triangle, triangle DEF. So the first thing I want to know is, if I want to go from triangle ABC to triangle DEF, so this is the original, and triangle DEF would be the new, I want to know the scale factor. So using this idea that scale factor is the new divided by the original, I'm going to use the two corresponding sides, which is 5 centimeters here and 10 centimeters here. For the new it is 5, and for the original it's 10. 5 over 10 reduces to 1/2. So that means my scale factor is 1/2. Now, so that means that to get from triangle ABC to triangle DEF, I would need to scale the side lengths by 1/2. Now, remember that area, though, area doesn't get scaled by the scale factor. Area gets scaled by the scale factor squared. So to find the new area, I'm running out of room, so I'm going to write down here. To find my new area, I'm going to take the area of the original triangle, which is 36, and I'm going to multiply that with the scale factor squared. And that will tell me the new area of my smaller triangle. So 36 times 1/2 squared. 1/2 squared, remember, is just 1 over 2 times 1 over 2. Multiplying across, that gives you 1 over 4. And 36 times 1/4 gives you 9. And that makes sense. We're going from a bigger triangle to a smaller triangle. So it does make sense that the area of this new triangle should be smaller. Hence, the scale factor was between 0 and 1. So, all said and done, our final answer for the area of triangle DEF is 9. Don't forget your units, centimeters squared. So this concludes the video for section 9.6 on similarity. Once you are finished, you should start the homework for tonight.